So hi everyone, and this is Sandeep. You are watching Samyans Academy, and in this session we are going to discuss about solution 2. And let us discuss this question now. And this question given in EAPCET 2023. The vapor pressure of pure liquid is 70 torr at 300 Kelvin. It forms an ideal solution with another liquid B. The mole fraction of B is given here 0.2, and the total vapor pressure of the solution is 84 torr at the same temperature. The vapor pressure of pure liquid B we need to find. Okay, the total pressure is equal to mixture of liquid A and liquid B. Pressure of liquid A and pressure of liquid B. Okay, then how do you find this pressure of liquid A? So we have a formula. So mole fraction of A into uh, yeah, the pressure of liquid A in its pure form XA into PA naught plus pressure of pure liquid XB into PB naught. Okay, the total pressure of the system is given is how much here? That is 84 torr. So this is a total pressure of the system given here, 84 torr, and they given that mole fraction of the B also, that is 0.2. And what is the vapor pressure of the pure liquid A is given here, that is 70 torr at 300 Kelvin. Then how do you find this mole fraction of A? So by using this formula we can find out. So mole fraction of A plus mole fraction of B is equal to 1. Already you know this, right? So what is the mole fraction of B is given here? That is 0.2. So from this we can calculate that mole fraction of A. Okay, that is how much mole fraction of A is. Mole fraction of A, so mole fraction of B is 0.2 equal to 1. So from this we can find out the mole fraction of A. So 1 minus 0.2 is how much it is? That is 0.8. 0.8. Okay, mole fraction of A is 0.8. Just you substitute the values here and you get the answer, right? So this is 84. Okay, so mole fraction of A we got now, that is 0.8, and the pressure of pure liquid A is how much they given? 70 torr. So into 70 plus mole fraction of B we have here how much? That is 0.2, and we need to find the vapor pressure of pure liquid B. Okay, just you calculate this, you will get the answer now. So 84.8 into 70, how much it is? That is 560. That is 56. 0.8 into 70 is 56 plus 0.2 into PB naught. This 56, when you take it this side, it will become minus 56. 84 minus 56 equal to 0.2 into vapor pressure of pure liquid B. Okay, then find out this answer. What is the value of 84 minus 56? 84 minus 56, how much it is? Yes, 14 minus 6, 8. 7 minus 5, 2. That is 28. So 28 equal to 0.2 into vapor pressure of pure liquid B. So into 0.2, when you take it this side, it will become by 0.2, right? This is the vapor pressure of pure liquid B. So 0.2, when you remove this point, just you put 0 here. So that is 280 by 2. What is the value of 280 by 2? Yes, 280 by 2. How much it is? Which is equal to 140 torr. So here, which one is matching your answer? The answer A is matching. The answer is 140 torr. And this is your answer. Okay, move on to the next question. At T Kelvin, the partial pressure of dissolved oxygen in 1 liter water is 1 bar. The concentration of oxygen in ppm. They given that Henry's constant value kh of oxygen at T Kelvin is 50 k bar, right? So we need to find the concentration of oxygen in ppm, means mg per liter or milligrams per liter. Ppm means you have to find the oxygen concentration in milligram per liter. Okay, and this question is related to Henry's laws. Okay, so what is the Henry's laws? Partial pressure of oxygen is equal to, right? Uh, this is Henry's constant into, yes, mole fraction of oxygen. Mole fraction of oxygen, right? So now you see this, in this question they given that the partial pressure of dissolved oxygen is how much? They given that is 1 bar. The concentration of oxygen in ppm we have to find out, and kh value they given that 50 kilobar. 50 kilobar. Okay, so this mole fraction of oxygen, first you find out by using this formula, mole fraction of oxygen. Partial pressure of oxygen given here 1 bar, right? So you put here 1 by kh value they given 50 kilobar. So this we can write as 50 into 10 power 3. Can I write like this? Okay. So can I write this one 1 by 5 into 10 power minus 4? Yes or no? What is the 1 by 5 value? 1 by 5 value is the 0.2. So can I write this 0.2 into 10 power minus 4? 0.2 into 10 power minus 4. Okay. So this we can write as 2 into 10 to the power of minus 5. And this is the value of mole fraction of oxygen. Okay. From this you find the number of moles of oxygen, right? Then how do you get this number of moles of oxygen from this? What is the mole fraction of oxygen? Already you know that mole fraction of oxygen is equal to number of moles of oxygen by number of moles of oxygen, and this oxygen is dissolved in 1 liter of water, right? Then number of moles of water. Then how do you get this number of moles of water? So to get the number of moles of water, we need to find another calculation here. Number of moles of water is equal to weight by molecular weight, right? So what is the weight of the 1 liter water? Already know that 1 liter of water is equal to 1 kg. Yes or no? Then 18 by 1000 you do, then you will get this answer, right? So weight by sorry, weight is 1000 and molecular weight is 18, right? The number of moles of water is 55.5. Okay, so this is the mole fraction of oxygen, and number of moles of oxygen by number of moles of oxygen plus number of moles of water. When compared with the number of moles of water molecule, this we can neglect. Number of moles of oxygen we can neglect, right? So this mole fraction of oxygen, so just we can write like this. Now you see here, mole fraction of oxygen we can write as number of moles of oxygen, by number of moles of water. So this number of moles of oxygen we can neglect. Okay, which is equal to what is that the value here? 2 into 10 to the power of minus 5. Now you see, when this number of moles of water already we calculated, how much it is? 55.5. Yes or no? Just you number of moles of water value you substitute here. Yes, just you substitute here number of moles of oxygen equal to 2 into 10 to the power of minus 5 into number of moles of water. Okay, so 2 into 10 to the power of minus 5 into what is the value of number of moles of water we got here? 55.5. Okay, just you calculate now. 2 5 the 10 and 2 5 the 10, 2 5 the 10. This is equal to, yes, how much it is? Sorry, triple one. Triple 1.0 into 10 to the power of minus 5. So this I am writing. So this is what moles per liter, right? So this is what moles per liter. This is number of moles of oxygen in 1 liter of water. How much it is? Triple one into 10 to the power of minus 5 mole per liter. So this we need to convert in milligram per liter. Then how do you convert this mole into grams? Yes, already know that number of moles equal to weight by molecular weight. Okay, so weight in grams. How do you get this weight in grams? Weight in grams equal to number of moles into molecular weight. Okay, so just to convert this mole per liter into gram per liter, just you calculate value. What is there here? Number of moles of oxygen equal to triple one into 10 to the power of minus 5. This value just you multiply with the molecular weight of the oxygen, and this value you converted into grams. Right now you see, number of moles of oxygen equal to triple one into 10 to the power of minus 5 into what is that molecular weight of oxygen? Already know that, that is 32. So now this value converted into gram per liter. Okay, this value converted into gram per liter. Yes or no? We need to find milligram per liter to get the value in ppm. So we need to convert this units in milligram per liter. Then how do you convert this milligram per liter? This triple one into 10 to the power of minus 5 into 32 milligram per liter means 10 to the power of minus 3, right? So this I am doing here, the remaining calculation I am doing here. 10 power minus 3 into this we can write milligram per liter, right? So triple one into 10 to the power of minus 5. So 10 power plus 3 you take. So 10 power plus 3 into 10 power minus 3. So milli means 10 power minus 3. Okay, to balance this, you just multiply with 10 power 3, right? So triple one into 10 power minus 5 plus 10 power 3 is how much here? Triple one into 10 to the power of minus 2 into 32, and this value in milligram per liter you will get here. This is equal to what is that? Number of moles of oxygen in milligram per liter. Oxygen concentration in milligram per liter. How much you will get here? 1.11 into 32. Okay, just you calculate this value 1.11 into 32. How much it is? 1.11 into 32. So 32, 32, 32, 2553. So answer is, after 2 digit you put the point. The answer is 35.52. Nearly we are getting the value here. Option B is matching. Now you see 35.5. The answer is 35.5, and this is the concentration of oxygen in ppm. So just now we converted in milligram per liter. Is it clear, everyone? Okay, and your answer B is matching. Okay, move on to the next question. Okay, now in this question they given the 3.1 grams of compound X they given, and molar mass of the X is how much they given? 62 gram per mole, right? So which is dissolved in 19.5 grams of other compound, that is having the molar mass is 78 gram per mole. The ratio of mole fraction of X and Y we need to find, right? So mole fraction of X and mole fraction of Y. How do you find this mole fraction of X? Before that, you find the number of moles of X you find. Means weight of X by molecular weight of X you find out. Weight of X is given here how much? 3.1 grams, right? 3.1 by, and molecular molar mass of X is how much here? 62. 3.1 by 62. How much it is? Use 31 table 31.1 times, and it is 2 times, right? So 200 to 2 3 times, right? 0.1 by 2. This we can write as 1 by 20, which is equal to 0.05, right? And this is the number of moles of X, right? Then number of moles of Y, how much it is? It is also same formula. Use the same formula, weight by molecular weight of Y. So weight of the Y compound is how much here? 19.5 grams. 19.5 grams. So which is dissolved in 78. Sorry, not dissolution. So it's a molar mass. Molar mass is how much they given? 78. 19.5 by 78. Just do the calculation. How much you will get here? So it is around, I think, 19.4 the 76 is plus. Okay, 19.5 one time, 19.5 four times. You will see 19.5 into 4 is 78. So this we can write as how much it is? 1 by 4. 1 by 4. Okay, this is 1 by 20 and this is 1 by 4. 1 by 4 we can write as 0.25. Yes or no? Right. So now you find the ratio of mole fraction of X and mole fraction of Y. So ratio of mole fraction of X and mole fraction of Y, how do you get this? So already you know that mole fraction of X formula is, just you convert this into formula, mole fraction of X by mole fraction of Y. So how we can write this? Number of moles of X by total number of moles by number of moles of Y by total number of moles. Okay, so this is the formula. So the ratio of mole fraction of X by mole fraction of Y, we can write less number of moles of X by total number of moles. Mole fraction of Y equal to number of moles of Y by total number of moles. Here these two will get cancelled. Nx plus ny, nx plus ny. So this formula we can write nx by ny. Okay. So what is the mole fraction of, what is the mole of X mole is 1 by 20, right? So this we can write as 1 by 20 by number of moles of Y is how much here? 1 by 4. Okay, this 1 by 20, and you make it reciprocal, this, that is 1 by 4 will become 4 by 1, right? So 4 how many times? 5 times. So answer is 1 by 5, so which is equal to 1 is to 5. Okay, the mole fraction of X and mole fraction of Y. So your answer, which one is matching here? Yes, the answer here A is matching. The answer A is matching. Is it clear, everyone? Okay, so let's move on to the next question. For which of the following liquid mixture the change in enthalpy of mixture is 0 and the change in the volume is 0? Okay, this is the ideal solution. So to get this, first you need to find which is having similar in nature and similar functional group, and that one is acts as ideal solution. Now you see which one has similar functional groups, and that one acts as the ideal solution. This is a technique to find out the ideal solution. Now you see this is ethyl chloride and ethyl bromide, and this is ethanol. This functional group is OH, and here acetone. This functional group is acetone means C double bond O. It's not the similar functional groups, right? And here we have the phenol. Phenol means OH, aniline means NH2, and here also there is no similar functional groups are there, and chloroform and acetone, here also no similar functional group is there. So in which option the similar functional groups are there? In the first option. What is that? Ethyl chloride. Ethyl chloride means C2H5Cl. This is a hollow compound, right? Functional group is halogen. And ethyl bromide, and these two are in similar in nature. The solvents which are in similar in nature, they form ideal solution. Right? Your answer is A. Remember like this. Okay. To find out the ideal solution, you see the if compounds are having the same functional groups or not. If they are having same functional group, we can consider that they will form the ideal solution. Okay. Next question. Which of the following condition is correct for the reverse osmosis? So what is the actual osmosis means? Osmosis means one semi-permeable membrane is there, right? So in this side we have the solvent molecules, and this we have the solution molecule. So in osmosis, what will happen? Solvent molecules flows from low high concentration level to low concentration region. Means water molecules flows from here to here. This is we called as osmosis. To stop this, we have to apply some reverse pressure. So in solution side, suppose when you are applying pressure on the solution side, then what happened? And this osmosis takes place in reverse direction. Okay, from solution to solvent, and this is we called as reverse osmosis, and this is we called as osmosis. Okay, to get this reverse osmosis, what we are doing, we are applying some pressure on the solution side. Then what happens? From these solvent molecules moves from here to here, right? Solvent molecules moves from the solution to high concentration region to low concentration region. Okay, for this movement you are applying some pressure, right? So that pressure we called as a reverse osmosis. Is it clear, everyone? Right? So in this, so how much external pressure you are giving? Some external pressure you are giving. Okay, so this is it has to more than the osmotic pressure. So this external pressure, whatever you are giving, it has to more than the osmotic pressure. Then only the solvent molecules moves from the high concentration region to low concentration region. That is means solution to solvent side, right? So here, which one is which option is correct here? Here option B is correct, right? The external pressure is greater than CRG, right? Next question. A liquid mixture is an ideal solution if it obeys ideal gas equation, it obeys Raoult's law at all concentration, solute solvent, and solvent solvent interactions are similar. Okay, a liquid mixture is an ideal solution, right? So when will you consider a mixture is an ideal solution, and when will you consider a mixture obeys the Raoult's law at all concentration? Now you see when when do you consider a mixture is an ideal solution? So you consider this when volume of solute plus volume of solvent. If it is equal to volume of solution, then it is ideal solution. And also it obeys Raoult's law at all concentration, right? But here given that ideal gas equation is different and ideal solution is different, and ideal gas equation is PV equal to nothing. There is no relation between the ideal solution and ideal gas equation. Okay, so we need not to consider the first option. And the second option, you see, it obeys Raoult's law at all concentration. Yes, this is correct, right? And the solute-solute interaction, solute-solvent interaction, and solvent-solvent interactions are similar in ideal solutions, right? Then which options are correct here? Which options are correct here? Right. Option B, 2 and 3. Where it is? Yes, option C. So the option C is the correct answer. But this ideal gas equation, it is related to states of matter, PV equal to nRT, right? We need not to consider this option, right? And move on to the in this question we have here which of the following is are not correct for methanol and ethanoic acid mixture solution, and these mixtures form ideal solution. For ideal solution, delta H mix is equal to 0. This change in enthalpy of mixture is 0. But here given less than 0, this is not correct. And for ideal solution, it obeys the Raoult's law, but here given does not obey the Raoult's law, this is also not correct. and delta H mix greater than 0 also not correct, and only this fourth option is correct. So it is an example of ideal solution. Okay, only 4 only is correct. The next question, which of the following are correct for an ideal solution? For ideal solution, uh, change in volume of mixture is 0, this is correct, and volume of solvent plus volume of solid equal to volume of solution, this is also correct. Delta H mixture, change in enthalpy of mixture is correct. Okay, and now you see here solvent and the gaseous molecules both are reacting each other. Okay, then this is not a ideal gas. Why? Because and these two are reacting each other. Okay, and this is not an example of ideal solution, this is not correct. So your option A, B, C is matching, so your A, B, C is here, so your option C is matching, right? At 298 Kelvin, the vapor pressure of pure water is 25 torr. The vapor pressure of water when 12 grams of urea and 36 grams of glucose is dissolved in 100 grams of water at the same temperature in torr is, right? Vapor pressure of pure water they given. How much they given? Vapor pressure of pure water is 25 torr. Okay, in the next sentence they are telling that, so they have taken 100 grams of water, 100 grams of water taking. Okay, to this they are adding 12 grams of urea and 36 grams of glucose they are adding. Okay, then this combination will give how much vapor pressure, this we need to find out, right? So vapor pressure of water we need to find out, vapor pressure of water in this combination. This, then how do you get this? We have a formula. Pressure of water is equal to mole fraction of water and pressure of water in its pure state. Okay, then use this formula, find out the pressure of water in this solution. Okay, now how do you get this mole fraction of water? So mole fraction of water we can write like this, this is number of moles of water by number of moles of water plus total number of moles of water by total number of moles. So here we have 12 grams of urea is there, so number of moles of urea and number of moles of glucose. Okay, so and find out this number of moles of water you find out. So now I'm doing here number of moles of water, number of moles of water equal to how much water we have taken here, 100 grams of water. Okay, so 18 is a molecular weight of water, 100 by 18 is, you will get here 5.55, right? Then you find the number of moles of urea, right? Number of moles of urea they given here 12 grams, and molecular weight of urea also they given, that is 60. 12 by 60 is 1 by 5, 1 by 5 equal to 0.2. So number of moles of glucose, right? So glucose, that is 36 by 180. So this combination 36 5 times it is 1 by 5 value is 0.2. Just you substitute here, then you will get this 5.55 by, you add all this 5.55 plus 0.2 plus 0.2, how much you will get here? 5.95. Just this is the mole fraction of water, just you substitute here in this formula, you substitute. So mole fraction of water is 5.55 by 5.95, and pressure of pure water is, vapor pressure of pure water is how much here? 25 torr into 25. Okay, just do the calculation. So it is, you will get less than 25, so that is equal to, it is matching it 23.32. when you do the calculation, then you will get this answer, that is 23.32 torr. The answer is 23.32 torr. This is a pressure of water in this solution, right? Is it clear everyone? Okay, which of the following will form an ideal solution? Which combination gives ideal solution? Ethanol and water, nitric acid and water, chloroform and acetone, and benzene and toluene. Now you see, observe among this, which combination has similar structure and that can give you ideal solution, right? And that combination give you ideal solution. So which combination has similar structure? So it's a alcohol and water is there, and it's acid and water is there, and it's a chloroform and acetone, and you see here benzene and toluene is there. Similar structure is there. So benzene structure is this one and toluene structure is this one. Okay, and this combination gives you ideal solution. Okay, so answer is your D. Is it clear everyone? and move on to the next question. Following units is useful in relating concentration of solution with its vapor pressure. Okay. Relative lowering vapor pressure is directly proportional to mole fraction of the solute. Already you know that according to Rolle's law. The answer is mole fraction. Okay. And move on to the next question.